Very. So only 2 points, then
Yes, sir.
we close. Okay. So here it is. It's a comparison of OSI and TCP IP model. And also we'll discuss OSI model respect of troubleshooting related, at least some basic troubleshooting points. We have a very hard time, like only 15 minutes, 20 minutes time. So within 20 minutes, there is a model called a DoD model, Department of Defense. Okay, Department of Defense model is there. Usually, all these computers, network, all these things are started from the military strategies only, defense related kind of stuff from their researches only. These are all outcomes. Later, it is divided into a separate subject. Okay, computer, IT related subjects, networking, like that. It is divided. So here it is all are different subjects. Okay, this is a called a DoD model. Okay, don't get confused. There is a DOS also there. In DOS also there is confusion something. So this is DoD, Department of Defense model. This is later named it as a TCP IP protocol suite, a TCP IP model. Transmission control, internet protocol. IP means internet protocol, because in TCP IP we are using IP addresses. Logical address is IP address use. Okay, IPv4 or IPv6 we are using. So TCP IP model. So DoD model, later it is become TCP IP model. So what are the layers in this model? Only 4 layers: application, transport, internet, network, access layer. Application, transport, internet, network, access layer. Some people think OSI and TCP IP differences. It's not differences, it's just a comparison. Okay. And some people think OSI model having 7 and this having only 4. There's some kind of advantage, disadvantages are there. No, guys, because OSI is, we already know it is a reference model. Okay, it is, this model is applicable for all the type of network models. The TCP IP is one kind of model which we are using. In TCP IP, 4 layers: application, transport, internet, network access layer. In TCP IP, application layer, that one application layer will perform all the task of application, presentation, session layered works in the OSI model, in a OSI model. Means one application layer in TCP IP. TCP IP application layer is equivalent to application, presentation, session. All these things will do it. Okay. So your open browser application, you are sending and receiving data. So your application layer one time only, it will convert into data. Sessions will be created there only. This tab, one session. This is one session. Okay. Like that. So session. Next. Transport layer and transport layer in the both OS and TCP, same to same. Same to same. Segmenting the data, add a segmented data to segment number and window size, TCP and UDP, protocols, port number, TCP source and destination port number, UDP source and destination port numbers are added. Means your protocols port numbers are added. So that is totally, we call it as segment. So we chop the data into the into multiple segments. So then a transport layer total data is become multiple segments. Multiple segments. So it is same in the both voice and in TCP IP internet. Internet layer is similar to the network layer. In network layer, what we are doing is we are adding source IP, destination IP to your segment, one segment. Right? Next, we are adding routing information, means how to send this data, which interface data has to be sent, which way that data has to be sent. Like that, we're adding routing information at network layer. Okay. Next, network access layer. In TCP IP, network access layer. It is will do both jobs. Data link and physical layer, both will be works. Data link and physical layer. So what is a data link will do it? It attaches source MAC address, destination MAC address to your packet from the network layer and added CRC, cyclic redundancy check. This is checksum data to verify at destination data is good or corrupted while it is transmitted. If data is corrupted, drop the packet. Data is good, accept the packet. Okay. So that is data link. This is a total one we call it as frame. That frame again convert into the bit stream based on your physical connectivity. It will convert into that bit stream again convert into that related signal. Okay. If you are using fiber optic based connectivity, light waves. If you are using radio connectivity, means Wi-Fi type of connection, radio signal 2.4 or 5 gigahertz connection. If you are using a Ethernet LAN cable, then it is converted into electrical signal. Okay. So we have a LAN cards, right? In a NIC, LAN cards, Wi-Fi adapters. Okay. These are all comes under in a TCP/IP network access layer because it do both the things, data link layer and physical layer part also it will do it. Okay. In our system, hardware part is these two parts. These are hardware part. This is software layer only. These are all software part. Okay. So these are the TCP/IP and OSI model comparison. Let's understand what is TCP/IP layers and OSI and TCP/IP comparison.
Yes, sir.
Very. Next, troubleshooting using OSI model. So we understand how this OSI model works. So this is troubleshooting using OSI model. Here it is. Any network related issues based on the error message or based on what it is showing, we can understand where is the issue from where we have to start it. So most generalization, most general, you don't get any idea. Then at least start from here. What is it? Physical layer. Means connectivity. Physical layer is about connectivity. Both systems are connected or not. Both source and destination connected or not. If it is through LAN cable connected, is it Wi-Fi? Wi-Fi based connectivity is there, then Wi-Fi is connected or not. Both are connected in the same network, means my source and destination both are in the same floor, same building. Both are connected either directly or indirectly. Means I'm using laptop through Wi-Fi and connected to my Wi-Fi router. So there is a desktop. Okay, there is a desktop. So that desktop is connected to network through LAN cable. So it is connected to the LAN cable and switch. And switch is connected to the router. Router is I connected to the router. Means not directly, but indirectly also we are connected. Source and destination both are connected. So I can able to communicate. So first check the connectivity. Check total connectivity. First initial connectivity and total connectivity from both source and destination. Second check is IP address. I think you understand already in the IP address classes. Okay. So what is the one network and other network? So if two systems need to be communicate each other in the same logical network, same logical and physical network, both systems want to communicate each other, their network ID must be same. Means their network portion must be same or network ID must be same. Right? I think you have seen that network ID calculations and what is network and host portions. In class A, the W is network portion. So in one class A network, the W must be same. In class B, WX means first octet, second octet must be same for entire network. in a class C, first three portions or first three octets are WXY must be same for in entire one single logical network. If network portion is different from two systems means both are in the different networks. Okay. So compulsory check the IP address, both source IP, destination IP. Make sure both are in the same network, means same logical network and similar same physical network. If the remote means the destination is outside of your network, outside of your physical and logical network, means IP address definitely it's different. For example, google.com, facebook.com, youtube.com, outside of your network, they have their different IP addresses. Okay, so that is where IP address seeking. So these are the most commonly very helpful in the troubleshooting. Any two devices are not connecting, check the connectivity, check the IP address, and test the connectivity with a ping command. You can also use ping command to test the connectivity between the devices. Both are able to communicate and like this. Ping. So my remote device IP address, this one. So from my laptop to that remote device, IP address is communicating. Means both are in the same physical and logical network. That's why I can able to come. Reply from destination. Meaning is I am able to send and receive packet to this system from my system. Okay. So check the IP address in both sides and test the connectivity between the devices using ping command. Finally, not finally, transport layer. So we understand transport layer is segmenting data, but in a transport layer also we are using TCP, UDP protocols for their port numbers. Either it is system built-in firewall or any antivirus system installed any antivirus firewall or whole organizational firewall. Okay, or OS level or especially application or entire organization firewalls. When I want to connect, for example, I have a remote server. It is a web server. I want to access its website. So I send a HTTP request. It's a HTTP website only. So I send HTTP request. And that server, it should accept this HTTP request. So first, my remote system, here it is. How this verification happens at the destination. At destination, how this verifications happens. You send a request means you are added source MAC address, destination MAC address, source IP, destination IP. These are to identify this device. Next, in transport layer, you are adding port number, protocol or a port number, TCP type or UDP type, whatever it is. If it is TCP type, it's under TCP port and it is under UDP. If it is, there is a UDP port and missing. What are the UDP port numbers in this communication? What are the TCP port numbers in this communication is also there. So from here we'll see that. So once you reach the destination, you check the what is incoming packet at data link layer. Physical layer, convert your signal into bitstream to frame. In data link layer, you take the frame and check the source MAC address and destination MAC address and your packet and CRC, right? Using CRC, it verifies the data is good or corrupted. If data is corrupted, drop the packet. Data is good, accept the packet. And check the destination MAC address. This destination MAC system, the system's MAC address, interface MAC address, and this MAC address, incoming packet MAC address. Both are same. Then accept the packet. Accept the packet at a data link layer wise. Next step. Network layer. Generally, we don't touch the data link layer, but network layer is we are having IP address. Okay, one point. We take this source MAC address. For example, source name is A. So we take this A device MAC address, put it into a table called ARP table. Take the source MAC address and put it into a table called ARP table. Next, network. Again, what is it? Source IP address. Destination, I said destination is B IP address and your segment. Okay, earlier I didn't much explain it. So again, we'll see because it will help for your troubleshooting mainly. You check the incoming packet, destination MAC IP address, check with your system IP address. Both are same, accept the packet. Then you take the incoming packet, source IP, put it that IP here in the ARP table, map to incoming packet, source MAC address. It will keep it in this ARP table. I just told ARP about ARP. Later we'll see what is this ARP in the future when if you any possibility of discussion, I will try. Okay. This is ARP table. Next. So what we are getting? So IP address is also verified. So we verify the destination IP address and our IP address same. Yes. Accept the packet. And what is the source IP and source MAC address? Put it in the ARP table. Now the actual data is in the segment only. A transport layer, these segments will be come. One packet came, one segment came. Like that, we receive a lot of packets from the source. Then we got a lot of segments. We combine all these segments and created data. But this segments also contains your TCP and UDP source and destination port numbers. Based on this port number, system can understand based on the port number. Based on the port number, system can understand which application will going to process this request. Up to here, network layer, we are identify the device. We reach the device. But at transport layer, the segments are also telling which service is a web related, mail related, remote connection related, okay, or authentication related, which kind of request you are sending. So that will be based on your port number. So that once system learn this port number and connect that port number related applications. So as I said, application presentation session in TCP IP, all are belongs to application. So all three are belongs to one only, one application related. So obviously based on your port number or a protocol number, it's sent for a processing that information. So immediately this port number related application is connected. For example, my destination system is a web server and the FTP server, mail server also, and DHCP server also. But you are sending HTTP requests. So HTTP application, HTTP related services that will be respond for your request. You send a mail request, mail server related services will respond to you. So how to identify based on your port number. So that is connected to your application. The point is here, guys, you are unable to access. You done ping to the remote system. You done ping to this destination system. So you are able to communicate, means you are able to reach up to the system. But you are trying to access port number 80, means HTTP, you are trying to access from this V system. From V system, you want to access a website. So what you done? You send HTTP or HTTPS request. B, check the request here. Is that request related? Means ATR, HTTP or HTTPS related processes there are not. That related services there are not in the system. If it is not there, you won't get any reply. If it is not there, then you don't get any page. Okay. If it is there, then it will provide. Means you are trying to open a website. It's not opening. Okay. But when you're trying to pinging is going on. Ping is good. Means connectivity is there. Means server is available. Server is available. IP address is correct. But that it is not providing that system with that IP address. That system is not providing web services. One option is it's not providing that related services, or the service is down, or the service is down or is stopped. Maybe there is that service related application has a problem. Okay, application layer level related issue it is. Okay, you got internet, you're open google.com, facebook.com are open, but particular website is not open. So that website is not open, or particular service is not connected. So what you will do, we check the connectivity, physical connectivity will check it, IP address will check it. Very importantly, we test the connectivity from source to destination IP, we test the connectivity. If pinging is good, means between the two devices, communication is good. But I want to, where is the problem possible? One of the possibility is application layer things. Means either it's not providing that services, or that related service is stop or down. Okay, maybe there is application related, some issue is there. Second one is firewall. Application is running good. Okay, web server application is running good. But this firewall is stopping this port number at server. Okay, the destination system stopping that port number or protocol. Okay, that's why I written here transport layer 4. What is this? Port number related. Okay, port number or protocol is not allowed through that system firewall. Means system is available, it verifies your data link layer, means MAC address is verified, IP address is verified, but you are not getting services. Either service is not available in that system, or maybe firewall is blocking your services. That is, so you have to check that system, firewall, this related service. First of all, you have to check the related services are running or not. Next one, you have to check the firewall is allowing the services or not. These two things you have to verify. Okay, guys, understand this part?
Yes, sir.
For example, I want to connect a database server, MySQL database server. So I use the port number, protocols, means port number, server IP address, username, password. I send a request to that server. The server verifies the source IP, source MAC address, destination MAC address, source IP, destination IP, verifies connectivity. Okay, up to that point is good. And I'm not getting connected to the database connectivity. I'm waiting for connection. So I got it down. So I do ping to the destination system IP address. Pinging is good. So where is the problem? Not connection problem. It is application level problem or firewall level problem. So you have to go to the server, means the remote machine. Verify that related application is really running or not. Application is running good, maybe it is a firewall. Firewall is the related port number is not open there or service is not open. Connectivity is not there. So that's why you are unable to get, or maybe your IP is not allowed. So like that at firewall level, we can also block. Next. Session layer, presentation layer, application layer. Session layer. So when you send a request for a first time, so the session is created here only. The session ID is created, session is created. This session ID will be saved here. Saved. Which kind of request, from which devices the request came. Okay, so that information is attached to this session ID only. What is your request? Everything is attached to this session ID. Okay, and it will save the session. It is what are the session ID I'm sending. So that session ID will take it and put what based on what is your request and it will link to this session ID. Means it establishes the session. Maintain till the transaction completed. Next. What are the data you are sending? That is already encrypted. So if it is encrypted, it is decrypt here. It is compressed, decompressed. 5 minutes. No, okay. Compressed, decompressed. Encoded, then it is decoded here. But in a presentation layer, one more point I want to tell. For example, one of my favorite open filler. Yeah, already I've written here. So this is a open filler is one kind of appliances for managing storage management related appliances, means pre-configured virtual machine it is. Then what I have done, so when we are accessing that appliance, we should access through web interface, web-based access on. When I'm accessing, I'm getting this kind of error. What is this? Pictures, images. This kind of error I'm getting. SSL version or cipher mismatch. This kind of error I'm getting. Okay, not like this. So SSL in bottom, you can see here, if you check, it is SSL related issue. What to do? Okay, not even like this. Showing SSL. 5 minutes. Okay. So where is this problem? Actually, what happened? Okay, so that is very old machine. So they take some Linux machine, install this open filler application in this machine. For securing, they put this SSL encryption. But this certificate encryption, encrypted certificate is there, which is inside of this machine. This is expired. 3 years back only it is expired. Initially, it is very clear, good connectivity. I can able to show the people the storage and all. The very easy, it's a open, it's free. But what happened when I'm trying to get connected? I'm getting this SSL related version mismatching. There is a multiple reasons. One is this certificate is expired because that's a date and time. Like a 2 years date is there, the 2 years is completed. Maybe 2003 itself it is completed because I'm getting problem from there. Maybe 2022 or 21 itself it is expired. From 2003 onwards I'm trying again. So it is not connected. I'm getting same kind of error. So one is server side certificate is expired. The second one is version mismatch. Maybe here it is version 1, but I am using version 2. Maybe it is version 2, I am using version 1 at the client side. Version mismatch. Client and server time synchronization. What is the third one? Time synchronization. So they have to synchronize. Proper time maintenance is also important. Server time is different time and source is different time. Not different time. They're not syncing. So exactly a common time, you can take a common time, time.windows.com common time. Okay. So for example, server is in US. Based on that US specific, based on the time zone, time has to be configured. I'm in India. Based on my Indian time zone, that time has to be configured. If I do mistake, like something wrong time configuration, time mismatches between source and destination, either source side or destination side, time mismatch is also there. You get a problem with this encrypted connection. Where is encryption is doing? Presentation layer. Encrypted related issue, presentation layer. Okay, either key means either certificate expiry or maybe version differences or time differences also possible. So finally, application layer. Application layer. So importance of application already told. If application is running, then only we are getting that related service. The response will give processed by your application layer only. You're sending a request and you receive response. So that request will be processed by application layer. So what are that application? For example, web related. Maybe Nginx application I'm using for web related process. That application will process your request. If application running, you will get it. Not running, you won't get it. One more point, that is the last point, and we go for lunch. Okay. This is one of my favorite example. For example, I want to open some page. So I send a request web page to the server. So this is a server. Request is HTTPS. This is the remote server. And I want this page, this URL. With this URL, I'm asking, I want this page. So what it is showing? Sorry, we can't seem to find these resources looking for. It means the server is running. IP address is correct. No firewall blocking. And the web application is also responding. Application is also running. Where is the fault? The page is not available. You can also see heading, title 404 page not found. Means this specific page is not available. The specific page is not available, not created, or maybe there is a page error is there. So like that, depends upon the error responses, we can understand where it can be the problem. Okay. Sometimes you are connected and left like that and immediately log out. Why log out? Session time. 3-minute session, 10-minute session, 1 hour session, 2 hour session. Times completed, session automatically log out. Okay. So this is session layer related kind of stuff. So depends upon the issue. We can understand where is the thing we have to verify it and how to verify it. And with the help of OSI, it's quite easy to understand this issue. Okay, yeah, I took more time than what I said. Okay, but it's okay. We completed. Okay. Any doubt, questions, guys?
No, sir.
So everybody got the point?
Yes, sir.
So we discussed about